First we have to open this file, magnetic levitation file, and open technical reference, user manual. So in that connections is explained. So you can see the connection wiring diagram. So we have to interface DAC card voltage amplifier with the equipment, magnetic levitation equipment. So this voltage amplifier is there. We can move on to that. So this one is voltage amplifier. From here we can give this cable to load to the coil, backside of this coil. Okay, and here we have the sensor output, light sensor. This light sensor, it has been given to this S1 S2 port. Okay, and we have the current sensor, this one. This is going to S3 port, and these outputs has been taken from here to ADC, and it is going back to DAC card. And then DAC card, we have to start from this one. Start from yellow, S1, S2, S3, S4. Now we have connected only S1 and S3. Okay, we can leave S2 and S4. So accordingly we have connected. S1 is going to channel 0 and S3 is going to channel 1. The same thing is explained here. S1, S3, the whole circuit will be completed. And motor output has been given to the DAC card with analog output port 0. So this one motor output is going to the analog output port 0 first. Start. Explanation about the equipment. This is magnetic levitation plant. Here we have three segments. One is coil segment, and another one is sensor segment and calibration segment. So here the ball will levitate, which is placed on the post. Below the post we have the light sensor. So light sensor will detect the ball whenever I place the ball over the post, and if I give the current to the coil, it will magnetize and it will try to levitate the ball. Before that we have to calibrate the sensor by adjusting gain and offset. So there is a calibration file is available in the file itself. If you go into the Quanser resource software, so there is a calibration file. So you can open this calibration file in MAGLEV and you can calibrate the equipment first. Stop. So we have to open the MAGLEV first. So from the MAGLEV we have to open the files, whichever it is in desktop. So this one, access desktop, magnetic levitation, with Quanser resource software. Then select folder, go to the calibration and open .mdl file. So it will open the file. So we have to follow those things. So in that file itself it is mentioned the script, the procedure which we have to follow. So before that we can switch on the equipment. So we have the separate switches. This is for volt pack and this is for DAC card. So there are two switches. Now it is switched on. So you can able to see in device manager you can able to see the Q8 USB. The DAC card is detected whenever it is switched on. If it is switched off, it will not show. And after opening the calibration file, it will show like this. So you have to follow the procedure number 2 and 3 for calibration of offset potentiometer and gain potentiometer. So here you can able to see it is manual switch. Initially it should be in up, and we can run the file. So we have to select this is up 0 amps, and we can run the file. So ball should be in resting on the post, and it will show the VB equal to 0. So now VB equal to 0.4. Because the equipment is not switched on, I will switch on the equipment. Backside we have the switch. So now you can able to see the sensor output, it is showing 0. Okay, if I change this switch to 0 to 2 amps, the ball will move on and it will stick on the coil. You just see. Here now it is sticked on the coil. Now it will show the different values. So now VB value is 4.6 and IC is giving 2 amps, which is minimum 4.75 we need. I have to calibrate that. So I have to adjust to this gain potentiometer to make it into 4.7. So I will make into 4.85. Okay, so now it is done. So now I will stop this. So calibration is over. So I will move on to experiment section. First we have to run the setup file. So in setup file we can choose auto or manual mode, and also volt-back should be in 3 amps, that is it is turned to 3s gain. So remaining parameter will be loaded once I run this one. So here you can able to see it is loaded, and here also it is loaded post space. So once this parameter is loaded, these values will be taken from this from the real-time program. So this is our real-time program. Here we have the input, and this is the air gap measurements, and this one is the controller. So we are having a PIV controller with feed forward output, and this is going to the coil. So this is going to the coil, and we are getting the output response from the ball position as well as current sensor. So these are the conversion PI controller inside that. This is for to make the coil current control, and finally we get the response coil current as well as this one ball position in mm. So now I am going to run this. By clicking the monitor and tune, it will done all 4 things at the single time, that is building, compiling, connecting to the target, and start. So once it is done, you can able to see the response. Ball is sticking. So now ball. So this is the ball movement. Now I will make it a 1. So you can see the response. This is the coil current. So if I give some more input, so you can find the coil current increased. Accordingly, the amplitude of the input signal is also increased. So the levitation of the ball is also you can able to show. So I will just decrease the can see the response. So if I make it 0, then it will be following the flash line. Stop. So in PIV control, we have the separate current control loop only for the coil current. So we can study only this coil current control in the separate file. If you open q_maglev_pi, so it will open like this, and here we can study only the coil control. Coil current control. Okay, this will not levitate the ball, but this will helps to levitate the ball. So now the coil current should be like this. If you increase slightly 1.6, so the coil current will be increased. So ball still it is on rest. If we increase 6.7, still it is on rest. We don't have the ball controller, so if it is more current, it will stick. So 1.5 it is not reacting, 1.8 it is reacting, so that is the limit. So within that we have to oscillate the coil current and we have to levitate the ball. So that is our task.